Electronics is one of the world's largest industries. A modern life is hard to imagine without smartphones and computers, which use integrated circuits to perform their myriad functions. Integrated circuits can contain billions of transistors, all embedded into a thin substrate of semiconductor material, usually silicon crystal. For the past 5 decades, these integrated circuits have been doubling their capacity every 18 months, allowing electronic products to become ever cheaper and more powerful at the same time. This is what we call Moore's Law, and it has played out for 50 years, but scientists are afraid that the technology may have met its limit. Back in the 1960s, the integrated circuit industry didn't know enough about how to manage the contact points between metal and semiconductor and couldn't understand how electric current flowed between them. Being able to describe the conductive properties of this contact point, known as the metal semiconductor junction, would be the key to transistor technology.
We're dealing with interface between the metal and the semiconductor. So when the carrier transport from left to right or from right to left, we want to know what happens.
Professor Simon Shi led groundbreaking work in both theory and experiments involving numerous materials and developed a playbook for how to manage intermetal semiconductor contacts by optimizing operating temperatures and doping ranges. This enabled large-scale circuit production and paved the way for many industrial developments in the next 5 decades.
Every electronic product has to based on integrated circuits. So very important. Start with iPhone, for example, and also your digital television, your computer.
But Moore's Law may soon no longer hold, as already densely integrated circuits reach fundamental physical limits. Transistors in IBM's new chips now measure just 2 nanometers across. That's narrower than a strand of human DNA. The most advanced microprocessor already contains 40 billion transistors.
I think the biggest challenge is how to make such a small devices successfully, and with billions of them on a single chip, which is only about the size of a fingernail.
Conquering these challenges is of paramount importance if we, as a species, are to find technological solutions to our global problems. Professor Shi believes young people have the capacity to invent new technologies and secure our future survival.
I really believe young people is the hope of the future, and some of the major problems, hopefully, they will eventually solve. I'm confident in the inventiveness and the discovery they can make.
For his contributions to understanding carrier transports at the interface between metal and semiconductor, enabling Ohmic and Schottky-contact formations for scaling integrated circuits at the Moore's Law rate during the past 5 decades, the 2021 Future Science Prize in Mathematics and Computer Science goes to Professor Simon Shi.